Aloha and welcome. In this lesson, we're going to be talking about string methods, and there's a lot to cover. Um, if you've taken a look at this, there's a lot of methods that we're going to be talking about, and I want you to look at it not from the standpoint of, oh my gosh, there's a lot of stuff I have to learn here. I want you to look at it from the standpoint that I look at it. Oh my gosh, there's so many tools here to make my job easier as a programmer. And it's kind of hard to see that, I'm sure, from your perspective, because this may be one of your first languages that you're learning. But take it from me, I have learned, I don't know, maybe 10, 15 languages already. And I have had that horrible feeling in the past of, oh my gosh, I wish I was able to do this. Or if I was having to do something, I would have to do it. I would actually have to program the functions that you're about to see. So instead of actually having a neat little one-liner that I could just throw in there, I would have to write a function that would be maybe 10, 15 lines long. And I wouldn't know if I'm doing it the most efficient way or the best way to do it. But now Python has all this figured out. So yes, there's a lot of things in there, but what that means is you have a tool for everything that you need to do. So let's take a look at that. So let me pull up VS Code here. And I've sketched out a lot of what I'm going to be going over, and there's a lot of things in here that I want to do on the fly as we talk. So we're talking about string methods here. So strings have a lot of associated methods that you can call to do useful things. They get these because they're implemented as a class. We haven't gone over classes yet. We'll talk about that later. Classes are kind of like a blueprint for objects, and these objects will include attributes and methods like functions. So anyhow, we're going to go over finding and replacing first. So we have this neat function called replace, and it can be used in a couple of different ways. One is we can replace a string, the old string, with a new string. And we can also do an old string with a new string, and we can tell it the number of occurrences that we want to replace. So we start with the string, and I just call it, I think smart people are smart because they look smart. And I did that because we have 3 occurrences of the word smart in here. And I'm noticing that before we do this, let me go ahead and knock out a bunch of code that we have in the rest of here, just so that doesn't get kind of loud when we're testing this. So the first thing I want to do is I need to show you, first of all, that when we replace something here, that we're actually creating a new string. So all these functions, remember, strings are immutable, and immutable means essentially that you cannot change them. So what happens is when we call a function, when we call one of these methods on it, it's going to create a new string. So if you want to store that, you can store it back into your original variable. But let's take a look at that. So we have string, and again, it's I think smart people are smart because they look smart. We're going to print that string just to show what it looks like. Then we're going to print the ID of it, and that's going to let us know what the actual thing is on the back, or the memory address in the background. Then we're going to say new string equals string replace smart with weird, and then we're going to print the ID of the original string, just to see if it has changed or not. It shouldn't change. Then we're going to print string itself to show you what it contains still. And then we're going to print the ID of the new string. And the new string should not be the same as string. And then we're going to print out the new string just to prove that. So then let's go ahead and comment this out. This may seem a little bit confusing, but let's run it and I'll go through it again. So what we've done here is we've printed out the string. I think smart people are smart because they look smart. So this is our ID, okay. Then we go ahead and we assign new string equal to this other thing over here. So this is proving, what's going to happen next is we're proving that this new string and the string actually point to different things. So this is our original string. This is our original string after making the changes there. And then we print it out just to show that, hey, it looks the same. And then we print out the ID of the new one that we created, the new string. And that comes out and you look at it and sure enough, it's a different ID here. So then we want to print out the string and also print out the ID, which is right here, and then print out the new string just to make sure that we're looking at different things here. So yes, they did create different they create a different string with the string.replace, and we assign that to new string. You could do something like string equals string.replace, smart weird, but in general, it's a good idea since it's going to represent something different. You want to name it something that's appropriate. So we usually have you do something like that. So anyway, let me go ahead and take this part right here and comment that out. Now we're going to go over here and we're going to show you the fact that you can also specify the number of times you change something. So we have smart and weird, and we're going to change it one time. So we're going to go up here and we're going to change this smart to weird, but only there. So we go and we hit play, and sure enough, I think weird people are smart because they look smart. If we were to change that and make it 2, you would see that we get, weird, weird, smart. So you can specify the number of times you want to do it. It's going to be moving from left to right. And that's how you replace strings. In the old days, you can imagine you're going to have to loop over a string, looking at every character, saving what you've accumulated, looking for that thing. And this is just so much easier. This is, it's so easy to replace something. You don't have to crawl on your hands and knees to do every little thing. They have a nice little method here that does it for you. So let's go ahead and comment that out. And now we're going to look at find X. So find X is a really useful thing. It helps you find the position, in what we call the index. It helps you find the index in a string of a certain thing. So to show you this, we'll take our first little example here, and we will say, well, let's undo it all, I guess. I'll explain to you what this is going to do. So we're setting up email. president@whitehouse.gov. And I used a very similar thing just the other day. I was trying to find all emails that ended in a certain domain. So I was looking for, I had a big list of email addresses. I need to find all the ones that were, let's say, hawaii.gov. So I had to go through each and every one. I looped through everything, and I did a find basically to see if it was in there. So I have email. Here is our example. Email is equal to president@whitehouse.gov. So I'm going to say period equals email.find the period. And this is going to give me the position at where we find the period. And that is over here. Then we're going to print out the position. Then we're going to say at is equal to the position that we find the at sign, which will be over here. Then we're going to print that out. And then we're going to say the user account is equal to, so the user account is going to be this part right there. So how do we find that? Well, we know it starts at the beginning and it runs up until this point. So we just talked about slicing in our previous lessons. So we know that we can slice it from the beginning. And since it's the beginning, we don't have to have anything in there. We don't have to put 0. We can just leave it blank. So we go from the beginning to the at sign, which is denoted by the at variable right here, which found us the position for that. So we go from the beginning to at. So then we're going to print that out. And then for the domain, we can get the domain as well. We know that the domain is between the at sign and the end. So we take the at sign, but not just the at sign. We don't want to include the at sign. We want to go one beyond it. So we're going to say at +1, and then we're going to do colon, and then we're going to leave it blank, because as we learned before, that goes all the way to the end here. So then we're going to print that out, and it should give us whitehouse.gov. So we go up here and we hit play, and sure enough, we find that the period is at character 20. So if you want to count that out, you'll get 20. And then if you want to find the at sign, president, and then boom, right there at 9. So when we go ahead and we grab user account, we say from the beginning to at, we get president as we expected. And domain equals email from at +1 to skip over the at sign over to the end. And that gives us the whitehouse.gov. So this is a way that you can take apart things. You can do things like taking apart an email address. You can take apart a file name, like if it's a something or another .doc or .pdf, you can find out what the base name is and find out what your extension is. Because sometimes when you're taking, let's say, an argument and you're looking at it and saying, oh, what kind of a file is this? This is a JPEG? Is it a GIF file? Can I do stuff on it? We have libraries that you can actually manipulate files like that. So sometimes you may want to check and see what kind of file you have there. And depending on what kind of file that is, you're going to use a different library to process it. So this is, how you get to that by doing these commands here. And there is a lot to learn here. And to be quite honest, what's important for you to remember is there is a function for it out there. You can always look up the function specifics later, and I often have to do that. I often forget, oh yeah, you can also add this parameter in there and get something else. You never have to memorize everything here. You can always look that up. Just know that there's a way to do it. There's an easy, simpler way to do it. And you're not going to have to build all this functionality from scratch. So that being said, let's go ahead and comment out here. And here is, so we just did find X. Now we're going to go to the next part, which is find X and start. So you can specify the start. So let's say you have a string here. Let's go ahead and I've created a monster of a demo here, but I hope it is of value. So what we're doing is we want to tell it where to start at. And I'm going to, this is an example, not the best example for how you're going to solve this problem. There's a much simpler way to solve this problem. But for now, I just want to show you this one here. But if we wanted to parse this thing out and find the first part, the month, the day, and the year, we can do that based on the knowledge that we have a hyphen in there. So to do that, I said that position equals 0 and last position is equal to 0. And what's going to happen is we're going to say, while position is less than the length of my date, we're going to loop over every character in here, and we're going to be looking for the hyphens. So we say position equals my date dot find hyphen, and we say position because this is going to be where we want to start at. So we're starting at 0. We're going to go until we hit 0, 1, 2. It's going to give us the 2th position. So we're going to find it at 2. Then we're going to say is position not equal to -1. The reason why we're checking for -1 is if we don't find the character, it's going to give us a -1. So if we put like an @ sign here, it's not going to find it. It's going to return a -1. So we're saying if position isn't -1, then we're going to print out that piece. So we're going to go from the last position, which is in this case 0. We're going from the last position to the new position, which is over here. So we grab those, and remember the new position, the second part, the end, is actually the end -1. So we were going up to the hyphen -1, so we're getting 0 and 1 there. So we print that out, and then we say last position is now going to be position, which is the hyphen +1, because that's where we're really going to want to grab from next time. So we then we skip over the else here. We go back up. Are we less than the length? Sure we are. So then we're going to say position equals my date dot find, another hyphen, and we're going to start this time at the position +1. So we're starting from here. So we go up to here and we find it, and that's going to be 0, 1, 2, 3, 4, 5, the 5th position. So we're going to this is going to be 5. And then is it -1? No, it is not. So we go in here, we take the part that is last position, which we set to here, and it's going to go up until here. So we're getting the next segment. And we do this until we get to the last one. So the last time we go through this, we're going to say position equals my date dot find the hyphen. We're going to be starting at this point, and it's going to say, hey, we don't have one. So it's going to return a -1. So we're going to skip this part here. We're going to go to the else. Then we're going to print that last number, which is 2024, going from last position to the end. And then after we do that, we have to break out of this, because what's going to happen is position is now -1, and that is less than the length of it. So we're going to have to physically break out. So this is a really bad example. There's a much better way of doing this, but I just was trying to find some kind of an example of why you may want to do something like use your start position. So this is the example that I came up with. Let's go ahead and clear this out and take a look at it. And sure enough, we get 0, 1, then 0, 1, then 2024. And this looks wonderful. It looks like, hey, wow, you know, our lecturer is really smart here. John's so smart. He knows this. He understands it. Yours truly ended up with a couple of situations where I didn't think it through well enough, and I got a couple of infinite loops, which goes back to something I mentioned about I hate while loops. I just don't like them, because if you come up to a situation where you're not actually breaking out of that, you're going to have an infinite loop. And that's exactly what I got, because I forgot that in the end, you're going to get a -1 from that. So when you're returned to -1, it's going to be less than that, and it'll just stay in that loop forever. So that informed me that we had to do a break to get out of there. So anyway, yeah, don't look at this and say, wow, I'm never going to learn to do that as well as he did. I spent quite a while making up this example earlier. So yeah, it's never on your first try that you're actually going to get something like that working. So don't worry. It just takes time, patience, and build it piece by piece. So now we've got one other extension to that. We have a start and we also have an end. So for this, I just have a simple example, some amazing apples at the market. And I'm going to say, start looking for A, but I want you to start at 4 and I want you to end at 8. So 0, 1, 2, 3, 4, we're going to start at the space, and we're going to go 5, 6, 7, 8 to the Z, and we're going to print the position. So if I'm looking at it right, I would say it's going to be 0, 1, 2, 3, 4, and 5. So let's see what happens here. And sure enough, we get 5 because it's finding it here at the 5th position. And remember, we're 0 base, so it's 0, 1, 2, 3, 4, 5. So you can specify that, hey, I only want to be searching in this range, here, something like that. So that helps when you're looking. You know that your text, there's only a certain portion of it you need to be looking at. Find the first, something in there, and you can do that. So let's see what happens if we put an AM in there. It actually works the same way. So it doesn't have to be just one character. It can be a string as well. So keep that in mind. Now let's move on to the next example. So going back to, this reminds me of something I just thought of. So we have rfind now. Rfind is reverse find. It's everything. There's an old saying that Ginger Rogers was twice as good as Fred Astaire because she had to do the exact same dance, only backwards in high heels. And this is, I just for some reason remember that. Rfind is the same exact thing as find, except it starts from the end and goes in reverse. So you can do the same thing. So if we want to leave this open right here, and we want to take that string and we want to reverse look for the dot, it should give us the last character there. So when we run it, it comes to 33. And sure enough, that is, I'm not going to read it, but if I wanted to test that, I could also come down here, just say, hey, tell me the length of string. And if we get that, we're going to see, boom, it's 34. So it's remember, it's 0 based. So that's going to be correct. So anyhow, so reverse find, you can find things going from the back to the front. So if you're looking for, let's say you want to find the extension for a file name, and it's somebody's used 2 periods within that file name. Let's say they call it john.johnson.doc, which is not a good name for a file, but let's just say they did it because I've seen that happen. If you do a reverse find for the period, you'll find the extension. So that's something to keep in mind. And trust me, I have done something like that, looking for the extension, and came across that one case. I was going through a directory and just pulling out all the files and looking for a certain extension, and my numbers were off because there were some files in there that had two dots in them, so 2 periods in them. So that threw everything off. So a reminder here, you want to use find when you need to know a position. If you just want to find out if the string or the character is in there, you can easily do that just by saying in. So you can say something like, oh, here I've got a nice little quick example. So print, got to go back up here and uncomment string. Let's go down here and clear out. So we're going to have the same string. We're just going to say, we're going to see if A is in string. So A is in string, true. What do I know is not in there? I was going to say Z, but that is not correct. Y is not in there. So if I look for Y, it's going to give me false. So you can use in to see simply whether something is in there or not. And you can use find and rfind if you're looking for the specific position. So keep that in mind. So a task like I mentioned earlier about finding the extension for the file, that's a good use for looking, for the period, actually looking for the position. Then you can go from the position on to get, or the position +1 to the end to get the extension for your file. So let's go ahead and comment that out. Then we're going to go look at our last part here, and that is count. And count basically is a nice way of counting the number of occurrences in a string of a certain thing. So we're going to uncomment that, and we're going to go back up. We're going to need our string up here again. So we're going to look for the number of A's in there. So if we run this, we're going to get 5. So if we look up there, 1, 2, 3, 4, 5. Yep, we have 5. So it counts the number of A's that we have in there, and that's a useful thing to have. And again, the thing that I just find so wonderful is I have had to write functions in the past in different languages that did this or implemented that. So these little methods that we have that we could just easily call here, these are methods that are born out of needing them in other languages. So it's just so wonderful as a programmer that's had to, as I said before, crawl on my hands and knees in other languages just to get that functionality. It's so nice just to have it, right there. So the next thing we're going to be talking about is comparing strings. So when we're talking about comparing strings, we use relational operators like the less than equals, greater than equal. And that basically compares character by character using the ASCII or Unicode values. And if one string matches another, but one is longer, the longer one is going to be greater than. So keep that in mind. Also, we have equality operators like the double equals and the bang equals, the exclamation mark equals. And to be equal, each and every character of the string has to match, and it has to be the same length, obviously. So keep that in mind. We also have membership operators, like I mentioned earlier, in, not in. And we also have identity operators, is and is not. We've covered this before. I won't really harp on that, but identity operators in general, you don't want to be using that. It's easy to mistake is with double equals. They're not the same. Identity operators, if you remember, it's actually talking about, are we pointing to the same place in memory? Are we talking about the same things? Are these two identifiers pointing to the same place in memory? So that's really the only time you want to be using identity operators, to make sure that you've got two things that are the same, not equal, the literal same thing. So you're probably not going to use that a whole lot. So just keep in mind that you're probably looking for double equals equality when you're doing things like that. So again, we have a ton of methods on strings here, and they are so wonderful because, like I've said so many times, we used to have to code this all by hand. We had to make our own functions. So millions of programmers across the world would make their own versions of this same functionality that was needed, that wasn't included in the earlier languages. So it's so nice to have it here. So I'll just run through some of these. Is AL num. This really is short for is alphanumeric. And what it's doing, it's returning true if, and all these are going to return true or false. And is alnum is going to return true if your string contains all numbers and letters, and the letters are uppercase or lowercase. Is digit is going to return true if all the characters in that string are 0 through 9. Is lower is going to return true if all of your characters in there are lowercase. And if you have things that don't have upper and lowercase, like a question mark, a period, things like that, that part of it will return true. It won't cause this to return a false. It's just looking at the alpha characters in there. So your alphabetic characters, are they all lowercase? If they are, and it has a period and a question mark, doesn't care, it's going to return true. And the same for is upper. It's going to be doing the same thing, only with uppercase. Is space is looking at, it's going to return whether it's going to return true if all your characters are white space. So let's go ahead, and I want to show this particularly because let's take a string and we're going to put a space. Then I'm going to hit it. Oops, hold on. I want to put a space and a tab in there. It's giving those parentheses because I'm using some type of thing in here, kite, that is sometimes it tries to guess at what I'm wanting to put in there, and it wasn't guessing correctly. So I've got a space and a tab in there. So let's see if that detects. Oh, hold on. So we're going to take that. Actually, we don't even need to assign a variable to that. So let's just take that, because that is a string. We can just say is space. And since that we want to print that, so let's go ahead and print that, and that should return true, because a space and a tab are all considered white space. So that's what I wanted to show you in that part. But there we go. So then we're also going to have starts with. So starts with, it's going to allow you to see if a character or if a string starts with a character, but this can also be a string itself. So we could do something like, let's do that print again, and then we're going to say our string is A, B, C, D, and then we're going to do starts with, and we're going to say A, and that should return. Let's go ahead and clear this out. That should return true. And no, we're going to get an error here because I did something wrong. And what did I do? Start with. Yeah, that's not the word, and I should have known that because it was white. So we hit that again, and it says true. Starts with A. Now let's see about AC. Should be false, right? Yes, false. But what if I said AB here? If I do AB, again, we've got true. And why? Because it did start with an AB. So you can do this for, to see if you start with a single letter, or you can do multiples if you wanted to do a substring to see if it started with a certain string at the beginning. So that's a nice little feature. And then ends with does exactly what you think it does. It checks to see if a string ends with a certain character or not. So we could have done the same thing here and just checked with ends with D or CD, something like that. So now we're going to talk about creating new strings from a string. So these are, again, really cool little functions that you can use. So we're going to use capitalize. Capitalize is going to capitalize the first word, the first character in a word. It's only the first one. So if you have something like, let's do print, and let's say we're going to print John Johnson, and then we say capitalize. So if we do that, it's going to capitalize only the first J, not the second one. So you look at it, John Johnson is what we get, lowercase on the J. But we do have something that we're going to see down here at the bottom that's going to capitalize both of them if we wanted to. And well, let me just cheat and put that down here at the bottom. So if we want to do this instead of capitalize, the function that we're looking for is title. So if we want to do title, then boom, John Johnson now. So that's going to give us, so if we wanted to do something like, hey, have a book, John Johnson learns, let's not do it for them, learns Python. And then we were to run that, we'd have John Johnson. It capitalizes the first one in here. It can get tricky perhaps if we have, let's say, an Irish name, John O'Sullivan. Oops, we're going to have to oops, I've got Japanese on here. So getting a, yeah, let's just, John, I'll cheat here. I've got Japanese on my keyboard, and it would take a bit of work to go ahead and get that backslash working properly. So I'm just going to cheat and change that to the double quotes because it doesn't matter. Now let's see how this works. Will it still do something like that? Let's see. Oh, it does. It does that correctly. Nice. Okay. Yeah. Okay, then that's good. I was worried about that. So yeah, in other languages, I don't think it would be as, I remember doing that in another language once where it didn't do the S. So that's nice to see. Then lower, lower is something, and upper is something that I use a lot when I'm trying to normalize uh, inputs from the system. So like if I have, sometimes when you run a program, you can send a parameter in to the program. You can say Python space, then the name of your file, and then you can put in what we call, arguments to it. So you put an argument, but sometimes you don't, or you do this with inputs too, when you're pulling in user input, and you want to see if they said yes. But how are people saying yes sometimes? Sometimes they'll do a capital Y, ES. Sometimes they'll do a capital Y, capital E, capital S. Sometimes it'll be all lowercase. So when you're doing an if, and let's say you're wanting to know if it's yes or no, then your if statement, you don't want to have to say if input equals capital Y, yes, equals capital Y, capital E, capital S, yes. So what we do in those situations is we use lower. So we'll do something like, let's say this was JO or something like that. Let's go ahead and assign this to name equals da, 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 da. So we just cannibalize that. So we're going to do print name dot lower and see what that gives us here. So, oops, hold on. Let me go ahead and comment this out so it doesn't look so. All right, so what we get down here is everything has been moved to lowercase. So the J, the O, they were all moved to lowercase. So if I was doing something like I wanted to test if the name is John Johnson, and I ran that, it would tell me true. So now let's say we had, really what we're looking at, is something like yes. Or if people, accidentally forget and they just do something like they fat finger it and they don't their input and they, do one that's not. So, and we're checking here. So we run and we say, oh, good, it's true, because we convert it all down to lowercase. The one thing that you may forget to do, and I've seen people, and I won't admit to doing this even though I have, but you go and you check upper, but you're comparing it to lower, and you're like embarrassed because why am I always getting it false when it was actually supposed to be true? And then you look and you say, oh, I was doing upper and I was actually putting in, yeah, I was comparing it to lowercase, so duh. So anyway, we do that, we get true. And then upper, as we just showed, does the opposite thing. So if we're going to do print name dot upper, we're going to see that it's all big yes. So there you go. And then strip is another one that you're really going to use. You're going to use strip a lot because sometimes when you get inputs, or when you, let's say you're reading something or file and you've got spaces in front of it and spaces at the end. So we can take something like print, we're going to put some spaces there, hi, then we're putting some spaces there, then we're going to say strip, and look at what this gives us. It's going to give us this beautiful, simple hi. It's not going to have the spaces on either side because we stripped out the spaces, and that is really convenient to have. And again, I'll just say this, the reason I love this, functionality so much is in the old days, some languages out there do have strip in there, but some of the ones that we started with didn't have that functionality. And again, you'd have to go through every character and take out your spaces. You have to take out your spaces. You have to take out your unprintable characters, your tabs, and things like that. And it was just miserable to do that. So having a function like strip here just makes it so easy. And you use these a lot when you're pulling in information in the beginning. When you pull in that value, like on a user input, you take it, you strip it off, and then you assign it, and then you use that from then on. You don't want to, use the strip every time you use that. Just go ahead, use it, normalize your variable there, and then use that from that point on. That way, you're not having to, keep on, cleaning it up every time. So that really is the majority of what I wanted to teach you in this lesson. It's a lot of stuff here, but again, I want you to just keep in mind that you can do these things. You don't have to memorize the syntax. There are references out there for you to do. I mean, it's good to know that you can do things. It's great to know that you can do these things if you want to. So when you're thinking up, hey, how am I going to go about doing that? And then you remember, oh yeah, well, I can find it there. And then if I can do that, I can, take this part or take that part. Understanding how you can use these functions, knowing that the ability is there, is the most important thing. You can look up your syntax and everything else later. And things like, the IDE, I'm using Visual Studio Code, it has all kinds of hints. And let's just go and take a look at something. Two things I want to show you here. So when I'm doing something like with a string, and I'm going to do something and I want to use a function, when you hit the period here, it knows that you're looking at either attributes or string or methods, so it can help you out. You can see that it's got is space, is title, is upper. It's got join, which we're going to learn later, and all these other things. So there's all this functionality you can see inside the IDE here. So this is IntelliSense. It's going to try to figure out what you've got there, but it's so great to be able to just go down there. And then let's say we're to take that, and then I start to open up the parentheses. Then hey, right there it tells me a little bit about the function that I'm looking at. That makes it really easy to do. There's another thing that you can do if you're not dealing with this. Let's say you were dealing with something else. Let's say you're in a Python interpreter. In an interpreter, you could use this function called dir. It's kind of like it gives you a directory of functionality. So let's say you've got dir str and you run that. It's going to tell you, hold on. Oh yeah, we kind of need to print that, don't we? So we print that. If you're an interactive developer, this makes sense. If you're in like an IDE like this, it's not going to make as much sense. But hit play and boom, you get all of the functionality that you're going to have in string. So you can take a look at that. And this is really nice to have. You can figure out what kind of things you can do with that thing that you've got. So yeah, and remember, you can also do things like look up the type. If you don't know what it is that you're dealing with, your variable, you've forgotten what is this thing, you can always look at the type and then, wait, hold on, type of string. So you can do things like, figure out what it is. Then once you do that, you can look up all your, you can do the dir of it and get your functionality and figure out what to do. So these tools are out there. In this day and age, when you've got something like an intelligent, IDE, integrated development and development environment is what that stands for. When you've got these things, all this stuff is there at your fingertips. It's wonderful. It's easy to, it's really easy to figure things out on the fly. And the tools are just wonderful. So if I do a dir, it explains everything to me right there. As soon as I open up that parentheses, it's going to tell me, what it does and everything. So anyway, I hope this has been helpful. If you have any questions, I know I kind of went over some of this stuff fast, but there's a ton of stuff here. There's lots to play with. Come up with your own situations to play with it. Find your own projects to do this in. You will use this a lot. I used a lot of the find functionality, and I was, like I said, I was parsing email addresses the other day and file names, and these are things you do a lot. So yeah. So anyways, if you have any questions, feel free to reach out, send me an email, set up a Zoom meeting, and I'll be happy to help you. And well, I'll see you in the next lesson. Take care.